am Kate Klein. I'm a faculty in the Mechanical Engineering Department, and we are going to take a look at the Material Testing Lab today. It's located in Building 32, C04C. And this laboratory is, I consent to this recording, by the way, and this laboratory is primarily used for mechanical testing, which services the courses of Mechanics of Solids, CVN 207, as well as MEC 207, which is Mechanics of Materials, and also MEC 205, which is Material Science, and any other senior project courses, which may need to utilize the testing apparatus for their senior project. So this particular lab has a capacity of around 15 students in the non-COVID situation, obviously less, about half that many in the current situation. But come on inside. So it's a fairly small laboratory, but we can service about 10 to 15 students in here. And we have our PPE with safety goggles and gloves over here, as well as a first aid station located in the back of the room. We have a projector on the ceiling, and a whiteboard projects onto a screen down here, so we can do the teaching for the laboratory instruction in this room. And then I'll take you here to one of the first stations. So in one of our laboratories, we'll set up at least 6 stations here, which will have the lever and fulcrum apparatus, where students can learn firsthand sort of with dealing with materials and the mechanical deformation of things like springs, as well as elastic rubber bands, and also tensile testing or fracture of other types of specimen, weak specimen like pasta. Towards the back of the lab, later on in the semester, we do actual mechanical testing on this 50 kilonewton maximum stress tensile apparatus here. So we've got it set up right now to test a brass dog bone specimen. We have our extensometer attached. And then all the data is output here to the computer, where we get our stress strain curves. So this instrument is useful actually for several experiments, not just only tensile testing of materials, but we can also run it under compression, and we use it also for 3-point loading or beam bending experiments. So towards the end of the semester, the students will design a beam for Mechanics of Solids and Mechanics of Materials courses. So we test not only standard beams, something like this, but we also compare it to the student design beams using the same raw materials, and compare the performance of the beams, such as this I-beam, or what we call maybe a pi beam type of design. And the students will load it with a 3-point system here, and the students will load it to fracture or failure, and compare the beam properties. Next, we'll move over here to the torsion apparatus. So here we test different types of material rods, so both hollow and solid rods. We compare them, different rods of different length, as well as different materials, to understand the torsional behavior of these different apparatus. We have also purchased a fatigue testing instrument that is in, it has not been set up yet, but it will also be part of this laboratory. Next, we have some measurement tools over here that the students can use to learn how to use these measurement tools, things like calipers and micrometers, as well as obviously rulers and other standard measurement tools, measuring the weights in order to accurately pursue the rest of the laboratories for the course. So this is one of the first sort of hands-on experiments that we do, is the measurement exercise. We have 3D printers where students can actually print tensile specimens and test those during class. And we have a hardness tester here, ultrasonic hardness tester. And then we have a thermal expansion apparatus here, where we test different materials, copper, brass, and aluminum, under heated conditions. Let's see. Oops. So you can see the outputs from the thermal expansion experiments. And that's pretty much it for this laboratory. Thank you.